Hi, welcome to this short video. In this video, we'll be talking about HMAC, hash based message authentication code. Basically, Macs are almost similar to digital signatures. The only difference is for digital signatures, we use a public key and a private key, whereas for this Mac, we just use one single key which is shared between the sender and the receiver. So it's like a symmetric encryption and decryption. Basically, this can be classified as that kind of operation. We'll be using BouncyCastle API, and we'll be using the HMAC class. So we'll see how to generate HMAC using different algorithms. So there are various algorithms, hash based algorithms, which can be used. Okay, so let's get started. Okay, so as I mentioned before, we will be talking about HMAC, or hash based message authentication code. So again, like my previous tutorials, if you have not watched them, please make sure to watch my previous tutorials, which should give you a fairly idea as to what's going on here, just in case if you have not seen them. So this is a UI which I have prepared for message authentication code generation, or HMAC to be specific. So what we need for this is a message itself, the key, and the algorithm, and to be used for computing the hash. So the way the HMAC is generated is the BouncyCastle class actually combines the secret key along with the message to give you the secure hash, I should say, which is what this HMAC is. So let's say if I use this is a dummy string, and for the key I will use the word passphrase, and say so these are the choices of the algorithms which we have in BouncyCastle. So I have entered in this drop down list, so which I'll show the code in a moment, but let us see. Okay, so let's choose MD5. So if I press generate HMAC, so it has generated this value, and we can compare it just to be sure that this is indeed the correct one. I'm going to visit a website called as cryptotools.net. So this is, as you can see, it matches exactly what we have here for MD5. So these two are a match here. So it matches, so which is what we can see. I've entered the same input string and the same key, and this is for MD5, so it's exactly the same. Let's try to say if we choose SHA 256, so we should be getting this HMAC. So let's try SHA 256. So I will say SHA 256 generate, and this is what we have got here, and let's see what do we have here. So again, as you can see, it's a match. So our code is working. Yeah, it's similar. So the code, so this is a way to verify that the code which is there, the BouncyCastle code and the C# code is working exactly as which we can verify from the in this case cryptotools.net website, which allows you to create the HMAC. So let's look at the code. It's not that complicated at all. It's a very simple code. As far as the UI goes, there is just an additional complexity of a drop down here, which is not that big deal. So let's go. I'll exit this application and let's look at the code here. So in the constructor, when we load the form, I populate the combo box with the various algorithms available. So all these are part of the iDigest of this class, the BouncyCastle class, which is available in crypto.digest, this one. And when we click the button, it calls a method called as compute HMAC, which is available here. and all it does is it just uses the HMAC class and passes the algorithm to use, which comes from the drop down and which is then shown in the output window. So it is as simple as that. So it is not that complicated to follow, or so this can be used as a starting point to learn about how HMAC is calculated. And finally, when we return back to the UI, we just remove the hyphens which are given as part of this do final of this class, and yeah, so we just return the result in the hex string. So what you are seeing on the screen is the hex string output. This one is the hexadecimal string. So yeah, that's it. I think this should be fairly simple enough to follow, and hopefully you liked this short video, which should be as I said a good starting point to computing HMACs. So thank you very much for watching. I'll see you in the next video.